Hello, my name is Richard Pham, and this is Lab 1 Charge Tapes. For the introduction, the purpose of this lab was to use the fundamental physics principles of Coulomb's law and Newton's second law to use data collected from experiments to calculate the excess charge on charged pieces of tapes. Materials used was clear tape, ruler, flat surface, and blocks to hold tape up. The main experiment, the system, was tapes and gravity/Earth, and the environment was air. A computer model was used to grow script, and a sneak peek of the results is that the Coulomb's law and Newton's second law was used to calculate the number of electrons that were lost, the charge of the tape, using setting the electric force equal to the gravitational force based on Newton's second law to then calculate the charge of the tape. Fundamental physics principles. So as said, Coulomb's law, which basically is the amount of force between charged particles at rest, and as given in the formula, it's equal to the Coulomb's constant, K, times the charges of the two particles divided by the distance of separation squared. And Newton's second law states that system change in motion momentum is proportionate to the net force acted upon the system. So basically, force equals to change in mass times velocity. And gravitational force is just gravity, which is based on masses of objects, as we know that gravity is 9.8 on Earth. Or meters, 9.8 meters over a second squared. Initial conditions, the tape was ripped from another tape stick to the flat surface, which then causes the top tape to be positively charged, and this will attract in my hand because the human skin is usually negatively charged. And then this is then used to have two negative or positively charged tapes to then use the bottom tape to cause the top tape to float, quote unquote. And as we see here, the system is at, or the force, the electric force is equal to the gravitational force because this is not accelerating. The top tape is not accelerating. This is the variables I use within the experiment and measured. So length of the tape was 0.25 meters. Then this used with density, calculate mass, tape width, tape area, all this measured, and then atom area is then used to get number of atoms, and then this between the tapes was also measured. This is then used within the coding as the coding questions, which we'll answer later on. And within the coding, these are all my variables that I used. And so tape A, tape B, tape A is the top tape, and tape B was the bottom tape. And charge was calculated by setting the electric force equal to the gravitational force because, as I showed earlier, the system was at rest, there was no acceleration. So then this was then used to calculate the charge of the tape. And this is then, we can then use force gravity, calculate that to get the arrows so that the experiment, it looks like what the experiment looked like, and then electron count was charge divided by the charge of protons. And then this is used with atom count to get the ratio. RA, RB, this is the position vectors, and a mag was used in the mag function. R hat is equal to the vector divided by magnitude. This is then used with the electric field, the charge of the tape, to then be used with the electric field times the charge to get to the force, electric force. These are results. So earlier, the magnitude of the charge of the tape was 1.35724 e to negative 8 coulombs. This is the force gravity and electric force, and then this is what it looks like. So the assumptions, we had to assume all of this because we had to ignore air resistance, and we had to treat the tape as a point charge and assume that the tape was evenly distributed to then have the coding and the formulas be more clean and less complicated. So the potential errors is obviously that due to the assumptions, the calculations are not going to be exactly where the experiment is. Inaccuracies with measuring, because we could not set the ruler right on top of the tape because it would mess up with the charge, we could have read the measurements wrong. And the other factors like the surrounding of the air could affect the transfer charges like humidity. So what if the electrons have positive charge and protons have negative charge? You see, this is just flipping the charges, which would not change their properties. So since the tapes were both the same charge, they would repel. And since the hand and the tape were opposite charges, they would also attract, even in this scenario. So why is it important to handle the charged states as little as possible? Well, what happens when the charged states come into contact with your hands or other objects is basically electrons move to positively charged objects to attain neutrality through a process called discharging, which is why we had to handle the charged states as little as possible because the charged states would no longer be charged and would be neutral if we handled it too much. And that is my lab. Thank you.